Hello, everybody. I come from Guangxi University, China. I'm so happy to attend this conference. My topic is the several kinds of lithium-ion batteries composition, analysis, and leaching for recycle. As we all know, the energy changed as time going from firewood to coal, then petroleum, and natural gas now. Because of the limitation of the traditional energy resources, we want to find a more clean and sustainable energy. So we have wind, solar, lithium-ion batteries, and hydrogen as energy. Today, I want to talk something about lithium-ion batteries. What is the composition of lithium-ion batteries? It always has five parts: cathode materials, anode materials, separator, electrolyte, and outside shell. The cathode materials always are aluminum foil coated with active material containing lithium, conducting agents, organic solvents, and use PVF expander. Anode materials will be copper foil coated with surface coating graphite, active substance, organic binder, separator with or PC, OP, and so on with membrane structure. Electrolyte with the few salts, including LiPF6 and other some lithium salts. Solvents such as EMC, and so on. Outside shell is aluminum alloy or steels. How do lithium-ion batteries work? When it is charged, lithium ions move from cathode to anode through the separator and go back to cathode when discharged. And every lithium-ion battery has three steps in its whole life. First, it works for automobiles. Then it can not work well, so it can be used as energy storage. For example, for house energy, provide energy for houses. At last, it has to be recycled. So the recycle is the destiny. It's so important. And everything has two sides. The spent depth has this bad influence. It will result environmental pollution, and heavy metal in spent liquid is harmful to people's health. It contains the highly toxic, flammable, explosive, corrosive electrolyte and organic solvent. But it also has good sides. It contains a lot of valuable metals. The degree of metal enrichment is better than mine. For example, this is metals in spent LNC lips. We can see cobalt inside is almost about 15%. Copper has about 14%. And these are used lips in our laboratory. This is charismatic batteries, and this is cylindrical batteries. We use the lips in this experiment with the lips used first. The post-packing. Our experiment method it contains the three main parts. The first is the dismantling. It contains discharge and the dismantling in water, manual separator. After separation, we can get outside shell, cathode, anode, and the separator. The second part is the thermal treatment. First, we drying and then heating. We investigate different gas and most temperature, and we make a compression between use brass and use ultrasound to separate the cathode powder and aluminum. Second part, leaching. We investigate the concentration of the acid, ratio of acid, liquid to solid ratio, and the temperature. We want to find the best option to to the experiment. This task was done by catching in the ego of legs in salt water and soaked for 12 hours. After soaked, we put it into the dry machine, dry for 6 hours in 80 degrees, and then do the dismantling. Investigation of metal components in cathode powder. This is the size of the post-packing used in this experiment. After separation, manual separation, we get the 4 parts. This is separator. It is plastic. It is outside shell. It is aluminum alloy. This is cathode material, and this is anode material. With a weight of every part. Total is about 300 grams, and outside shell is 7.9 grams. Membrane is 10 grams. After calculating equal, we can know the electrolyte is about 48.2 grams. Area is about 105.1 grams. Cathode is about 104.6 grams. And I want to know what is contained in the cathode black powder. So we put the cathode black powder into an anchor region to dissolve it, and use LCP to measurement the concentration. After calculation, we get the weight percent in cathode black powder. Lithium is about 6.58%. Manganese is 18.03%. Cobalt is about 12%. Nickel is about 32.5%. And the composition inside, the lithium is 1, manganese is 0.35, cobalt is about 0.23, nickel is 0.59. So we can get a result. This post-packing is NCM523. And I want to know which is the best option to remove the bundles. So we did the TB of cathode in different atmosphere to investigate the temperature to remove the bundle. The left is argon atmosphere. The right is nitrogen atmosphere. The temperature is from room temperature to 1000 degrees. And we can see these two pictures. There is not a large difference between them. And we can know from 300 degrees to 600 degrees, there is a weight loss. And when the temperature is increased over 600 degrees, the AC has some peaks and something happened. We know, as we all know, the aluminum measuring point is about 660 degrees. So in the experiment, we choose 3 temperature point, 400 degrees, 500 degrees, 600 degrees. And this is photos of heating of cathode materials in different atmosphere to remove the toxic gas and bundles. First, we use scissors to cut the cathode material at this size square and put it into the dry machine for 6 hours in 80 degrees, and then put it into furnace. We increase the temperature from room temperature to the target temperature in 30 minutes and stay for 90 minutes. This is pictures of different parameters. For the argon atmosphere and the nitrogen atmosphere at the temperature 400 and 500, we can separate cathode material and alumina very well. But when the temperature is 600 argon or nitrogen, something happened. The cathode material was destroyed. We cannot separate cathode material, cathode black powder well. And consider about the price. We use the nitrogen as the atmosphere to separate the cathode black powder and aluminum because it is than argon. And we also investigate how to separate aluminum and cathode powder. We compare brush treatment and ultrasound treatment. Because of ultrasound treatment, high energy, it destroys the aluminum core, and we can see here some small powder, aluminum powder, and there will be the impurity with the cathode black powder. But if the brush treatment, the aluminum is not be destroyed, it can be separated completely. So we use the brush treatment to separate aluminum and cathode black powder. At the third part, the leaching. First, we investigate the acid ratio change of ascorbic acid and nitric acid. We put 2 volume% cathode powder into this liquid. The acid concentration, 1 mole per liter ascorbic acid and 1 mole per liter nitric acid. These are results. We can see for the lithium, when the volume 1, we can see the highest rate, similar to the cobalt, manganese, and the nickel. So the lithium acid ratio, we choose the 1:1. And we also investigate the lithium concentration. The ascorbic acid and the nitric acid, so the same concentration of the ascorbic acid and the nitric acid. The volume ratio of this two acid 1:1, and we can see the last picture for the lithium. Also, we can know 1 mole per liter is the best condition, similar to the cobalt, manganese, and nickel. So we choose the 1 mole per liter as the best parameter. And then we study the lithium solid to liquid. The volume ratio is 1:1. The lithium reagent concentration is 1 mole per liter. For lithium, when the solid to liquid equals 30 grams per liter, the lithium rate is the highest. But for cobalt, manganese, and nickel, the solid to liquid ratio equals 20 grams per liter. We are getting the highest lithium rate. So we because it's free and just listen different. So we choose the 20 grams per liter as the lithium solid to liquid ratio. Last, we investigate the lithium temperature. For and the volume ratio is 1:1. The lithium reagent concentration is 1 mole per liter, and the solid to liquid ratio is 20 grams per liter. For the lithium, just 40 degrees, we can get the almost 100 lithium rate, and it is similar to the cobalt. For the lithium and cobalt, we can use the low temperature, but for the manganese and nickel, we just can get the almost 100 lithium rate at the temperature 85 degrees. So we consider this phenomenon. We choose the highest temperature as as a lithium fermenter. Conclusion. The used lips in bus has been studied. The composition of cathode is NCM523. The cutting and the discharge of lips has been done in the salt water. After drying of cut lips was heated in nitrogen atmosphere at 500 degrees for 90 minutes to remove the phantom. The cathode powder was lit in the following conditions: ascorbic acid and nitric acid, and the volume ratio is 1:1. The concentration of both acid is 1 mole per liter mixed. Solid to liquid ratio is gram per liter. The temperature is 885 degrees. The leaching percent of lithium, cobalt, manganese, nickel are almost 100%. Thank you for your attention.